In this video, I will discuss the benefits of IP routing in the Trio Q licensed data radio, as well as show the basic configuration required. There are various topologies available when using a Trio Q data radio system. Any of these may be configured when using IP routing mode. However, the multiple repeaters topology at the bottom of the screen is only available when using IP routing mode. Trio radios can operate in either of two basic modes. In transparent bridge mode, the radios will pass all data. In IP routing mode, however, OSI Layer 3 rules are used. Radios are then configured to route or forward specific traffic between local area networks. Each radio will behave as an IP router, basically a gateway providing access to its local area network. Designers may segment a wide area IP network into smaller subnets. This can provide faster pole times, higher throughput, or improved IP address management, all of which are vital for larger systems. Each radio and devices connected to its physical LAN ports will exist as part of a unique local area network. Local traffic stays on the LAN, reducing radio transmissions. Each radio has a second IP address, which is the WAN or Wide Area Network address. All radios coexist on the WAN, which is separate from all of the individual LANs. In the default transparent bridge mode, each device is configured with a unique IP address within the same subnetwork, with the size of that subnet fixed by the subnet mask. In the radio which is to act as the repeater, the peer-to-peer repeat feature must be enabled. No more than one peer-to-peer repeater is allowed in a transparent bridge system. Let's have a look at IP routing mode. Each radio and locally connected devices are provided addresses within the same local area network. For example, the entry point radio's LAN address is 192.168.1.1, while the host computer's address is 1.2. The remote radio's LAN address is 3.1, while the locally connected RTU is configured with address 3.2. We then need a wide area network IP address for each radio. In this example, the entry point radio is 10.10.10.1, the repeater is 10.2, and the remote is 10.3. Also note that each device connected to a radio must have that radio configured as its gateway. This allows the device to send traffic outside of its own LAN when necessary. Now, each radio and its locally connected devices exist on a unique LAN, while at the same time, all of the radios exist on a WAN. Now, to allow traffic to be routed or passed between local area networks, each radio must be configured with routing rules. The entry point, for example, must have a rule describing how to reach each distant local area network. In this case, to reach either 192.168.2 as a network or .3, the traffic must go through the WAN address 10.10.10.2, which is the repeater. The repeater itself must have routing rules describing how to forward or repeat data to the entry point and remote LANs via their locally connected radios' wide area network addresses. Before we end this video, let's have a look at how these parameters are configured in a Trio Q series data radio. We are now looking at the home page of a QR450. To configure the radio, we must first go to the Setup menu. To configure the LAN address, we go to the Network Configuration page and scroll down. You can see here the IP address is 192.168.2.1. This is the repeater in our example. The subnet mask has also been changed to segment the local area networks. We need to go to the radio page to enable IP routing mode. There are other parameters, but for this example, we will presume that the radio system is already operating. You can see here that the operating mode is IP routing. The default is transparent bridge. However, we cannot configure IP routing until after we have made this change. Only after selecting IP routing mode can we configure the IP routing page. First on this page, we must enter the radio's WAN address. From the example shown earlier, we know the repeater's address is 10.10.10.2. We must then enter appropriate static routes, one for each network that the radio may need to forward messages to. The first item in each rule is the destination network the message is intended for, followed by a space, then the subnet mask, which helps segment the system. Next, separated by another space, is the WAN address the message is to be forwarded to. The radio with that WAN address will receive the message and then either send it to its LAN if appropriate, or forward it again on the WAN using its own routing rules. These are the basics of how to configure a Q data radio for IP routing mode. Thank you for watching this video, which discussed benefits of IP routing and then showed the basic configuration items required.